Welcome to another podcast. In this episode, we're going to be looking at a slightly different application of simple interest, and that's determining the interest rate. In the previous problem, we had determined the future value of an account as well as the total interest earned. Here, we're going to know both of those values, but we're going to use it to figure out the rate. Oftentimes, figuring out the rate that you're being charged is a good way of figuring out which of two different options is a better option to go with. And so we're going to illustrate that in this particular problem. So we're looking at buying a bike, and the purchase price for the bike is $2,000. We don't have $2,000 on us, but the shop that we're buying it from is going to let us sort of do a layaway or an installment plan. And the first thing that they'll let us do is if we pay $1,000 now, then 6 months from now we'll owe them $1,150. Or I can give a little bit less down. In other words, I can pay $500 as a down payment, but then I'll owe them $1,700 6 months from now. And what I want to know is which of those two options has a higher annual simple interest rate. And so I want to start with the first option, so I'll just call it option 1. And in the case of option 1, let's describe the variables. So let's start with the principal amount. The principal amount of the loan is the amount that you are borrowing in a sense. And so this is what some students have trouble with on these examples. The principal amount of the loan is $2,000. And so the interest rate is what we want to find. So we want to find the interest rate. And the time span here that we have is 6 months, which, remember, T is in terms of years. That equates to a half a year, or 6 out of 12. The future value is the amount we're going to end up paying back. And for option 1, the bike costs $2,000, but by the time we're done paying back, we'll have paid $2,150. All right. And so the total interest that we've paid then is what? Well, if the bike costs $2,000 and we're paying $2,150 for it, then they're charging us $150 in interest. So we should be able to figure out exactly how much money that we're going to, or exactly the rate that's involved. However, I want to say one more thing here, and it's one thing that may have sort of escaped you on this problem. There's a difference in the amount that we pay down. And that's sort of interesting here because we need to make sure that we're calculating the correct things. Yes, the bike costs $2,000, but in the first example, I paid down $1,000. So I actually only owed $1,000. So the principal is the initial amount owed. Likewise, the future value is the amount that I have to pay back. And if you look at what they have, the amount I have to pay back is not $2,150, but it's actually, in the first option, I'm going to pay them back $1,150. It's $1,000 less. So this is actually the variables that you should have for this problem. You owe $1,000. You're going to have to pay back $1,150. The interest is still $150. The difference between that is $150, but that does affect how we're going to work the problem. So I'll just work it out here to the side. I want to solve for the rate, so I know interest is principal times rate times time, and the interest is $150 on $1,000 owed at an unknown rate for the course of 1/2 a year. Now notice, if you had left $2,000 in the problem, that would be a very different answer. We would have $2,000 here. So make sure that when you identify the principal amount, you're identifying the initial amount that you either owed or the initial amount that you invested. So if I solve for R, I could do that algebraically, and so let's go ahead and do that. I'm going to multiply both sides by 2 to cancel the 1/2. So this would be 300 equals 1,000 R. And if I divide by 1,000, I get 300 over 1,000 equals R, which says that R is equal to 3/10 here, which is 30%. So it's a pretty high interest rate, not surprising. Most little layaway, short-term layaway plans do have high interest rates. Now, if you wanted to do this in your calculator, we kind of tend to keep this course an algebra-free zone as much as possible. So I wanted to show you how you would go about doing that. If you go ahead and hit this solve button, it opens up sort of the command structure for that. And all I do is enter the equation, which was 150 equals, in this case, it was 1,000 times, I can change R to X, so I'll just call it X. 1,000 times X times, remember T on this problem was 1/2. And so if I hit solve again, then what it does is it solves for the value of the variable. In this case, the variable was X, and so it gives me the value of the variable being 0.3, which matches what we got algebraically here. So that's just a quick glimpse at the solver in your calculator that you can use to help you on several of these equations. Let's go ahead and look at option 2 now. And since we've discussed option 1, it should be a little bit easier to write down the components for option 2. Starting with the principal, the amount owed for option 2 is because I paid less down. I paid $500 down on option 2, then I still owe $1,500. I'm borrowing essentially $1,500 for the bike purchase in example 2. The rate is still the part that's unknown. The time is the same. It's still a half a year. The future value is the amount I'm going to pay back, and I'm going to pay back, in this case, I'm going to pay them another $1,700. So the idea here is when you're looking at this, I'm going to owe a total of, so let me just put it this way. I'm going to owe a total of $2,200, right? But when I look at the problem, the idea is that I'm going to only pay them back $1,700, so the future value here is, just like it was on this previous problem, I'm really only going to pay back $1,700. You can see I'm paying them $1,700. Because $500, the difference between $2,200 and $1,700 is $500, and that's what the down payment was. And so finally then the total interest that I'm owing is I'm paying a total of $2,200 for something that costs $2,000, so the total amount of interest is $200. Alright, if I then compare that using I equals PRT, I've got 200 equals the principal amount that I owe of $1,500, and then the rate and the time. And so I'm going to solve it similarly. I'm going to multiply through by 2. So I get 400 equals 1,500 R. And so R is 400 divided by 1,500. And so if I do 400 divided by 1,500, I get a rate of 0.267. We can just go ahead and round it. So a rate of 0.267, which is a 26.7% interest rate. So the better option of the two is option 2, purely from a rate perspective. Now there are other considerations here. Option 1, I pay $50 less than I do in option 2, because in option 2 I owe $200 interest as opposed to only $150 for option 1. The big difference though is how much money I had to put up front. I had to put twice as much money up front for option 1 than I did for option 2, and because of that the interest rates are actually lower for option 2. And so this kind of goes into the opportunity cost of money. The idea is, could I have done more with the extra $500 I'm saving initially? Could I have earned more money to make up the $50 difference between the two interest rates? And so that's one of the things, is sort of a give and take here. Is the interest rate more important, or is the amount that I'm paying at the end of this process more important? And that's going to be a decision that we're going to wrestle with throughout the entire unit. But this is just a little bit more sophisticated example of simple interest. It's a little bit harder example, harder to identify the principal amounts as well as the future value amounts. And so I just wanted to take a look at this one with you. All right, thank you for watching.